So the poll is still going on. So the poll is still going on. Okay. All right. So I want to believe that by now we should have completed the poll. So we are moving straight to today's class. And that's a quick review of what we have done before. So that is bearing and distance. Okay. Yeah. So bearing and distance, I think for some weeks now we have started that the area of trigonometry. And I think today is the 5th week, the 5th class we'll be having. So sorry, let me end the poll. I think I need to end that poll. Sorry. So like I said, today should be the okay. Let me quickly end the poll here. Okay. So nobody has filled the poll. Okay. So I still want to believe that you are solving the questions. Okay. No problem. Let's quickly end it here. So we can try. We can also bring it back later. Okay. So bearing and distance. What do we actually want to look at today there? We are going to use this opportunity to take a look at what we have done before. Trying to, okay. So before now, we have looked at trig ratios, and we have also looked at sine and cosine rules. We have also looked at bearing as a whole, the compass bearing, and the 3-digit bearing. So we quickly do a recap today. Trigonometric ratios. We were able to look at when you have a right angle triangle. Before then, we actually looked at the Pythagorean theorem. That is when you have a rectangle triangle and then you are given 2 sides out of the 3 sides. With Pythagoras theorem, you can actually find that. And then from there, we move to trigonometric ratios. Trigonometric ratios, that was where we look at the mnemonics. The so, ka, twa. So, ka, twa. That was the mnemonics we looked at then. Majorly, we looked at trig functions. And the major trig functions are sine, the cosine, and the tangent. So our conclusion then was that sine of an angle, call it theta, equals the opposite over adjacent. We also talked about cosine, that cosine of an angle, say theta, equals what? Adjacent over hypotenuse. Adjacent over hypotenuse. And likewise, we also talked about the tangent of an angle, say tan theta, as what? Opposite over adjacent. Opposite over adjacent. So we were able to look at this. So from SOHCAHTOA, that's where we got all this. And we said, we explained what we mean by hypotenuse. Hypotenuse is the side that is facing the angle 90 degree. Hypotenuse. This is the hypotenuse. So this is the hypotenuse. And we will now be given a particular angle, say this angle theta. So the side that is opposite to angle theta is known as what? The opposite. Why the third side is what? The adjacent. So that was our conclusion then. So that is everything we need to know about trigonometric ratios. So here you can see that we have 3 things. In each of the formula, we have theta, 3 parameters. Theta, we have opposite, we have adjacent. So anytime at all we need to use any of those, we must be given 2 out of those 3 parameters highlighted. So anytime you have been given the opposite and the adjacent, it means you can easily get your theta. Anytime you have been given the theta and the opposite, and you want to look for the, sorry for that. Sine theta is opposite over hypotenuse. Sorry. A very big error there. Let me quickly correct that. This. Okay. So this is it. Sine equals opposite over hypotenuse. So that is opposite over hypotenuse. That's why we have it as O. So when you have been given hypotenuse and opposite, so it means it's easy for you to find your theta using sine. And use sine to find your theta. Anytime you have been given the theta and maybe opposite, you want to find the hypotenuse. So that is also when you use sine. So majorly, if you need to find anything at all, you must have been given 2 out of the 3 parameters. You can see this is a parameter, this is another one, this is another one. So you must be given 2 out of what? Out of the 3. So that is on that one. Now we now extended the formula to when you have non-right angle triangle, say a triangle of this manner. We call this A, B, C. The first thing we made us realize is here is trying to label our sides. All the angles are labeled already. This is this, this is this. So now to get the sides labeled, you look at the opposite angle, opposite sides to what angle A is called small side A. So we also call it the corresponding side to angle A. So our small b will be what? The opposite side to angle B. So which is this? That's B. And small c is directly opposite to angle C. So having known this, having been able to label in this manner, the next thing for us to do is, when do we apply, what is sine rule and what is cosine rule? So when we say sine rule is what? Is the ratio of what? The side, ratio of a side to what? To the sine of its angle, of its corresponding angle. So saying that the ratio of the side, ratio of the length of the side to the sine of its corresponding angle is constant. So meaning A over sine A is equals to B over sine B, which is equals to C over sine C. It's a constant. So that is so we also talked about where do we apply it. Because of the fact that in mathematics we cannot use two equality signs at the same time. So we can only maintain one. So for us to, for example, now if you need to maintain these two, this equality sign. So it means we are talking about 4 parameters. 1, 2, 3, 4. Big A and small a, big B and small b. So for us to be able to find this, for us to be able to find anything here, it means you must be given 3 out of the whole of the 4 parameters there. And to give you the 3, it means they must give you a complete one, either A and A, small a and big A, or small b and big B. So, and then they will give you 1 out of the other. So, for example, if they give us A, small a, side A, and what? Angle A, and they give us maybe side B. From there, we can use that to calculate angle B. So in that, what we are trying to say in summary is that for you to apply your sine rule, it means that what? We must have 2 same letters, or we say that we have an angle and its corresponding side, whether angle A and small a, or angle B and small b, or angle C and small c. You must have what? A side and its corresponding angle, or an angle and its corresponding side. So that is where we can apply the sine. We have done some other examples the other time. So for compass bearing, too, we said when we can apply the compass bearing, cosine rule. Let's look at cosine rule before going to compass bearing. Now, for cosine rule, we also talked about cosine rule, that when do we apply cosine rule, and what is even the statement of cosine rule? There, when we say cosine rule, let me just give one out of the various forms. It's just an improvement to Pythagoras theorem. So a squared, a generalization of Pythagoras theorem. So we can have a squared equals to b squared plus c squared. This is Pythagoras theorem. But now we are now improving it to accommodate a non-right angle triangle. So in that case, it will be minus 2BC cos A. You know, in this case now, when the when it's a right angle triangle, it means A is 90 degrees and cos 90 is 0. 0 multiplied by 2BC to also give us 0. So by that time, it will have reduced to your Pythagoras theorem, which is A squared equals to B squared plus C squared. So that is that one. So I haven't done that. So this is major thing about cosine rule. So I haven't stated the cosine rule. When do we apply it? When do we apply the cosine rule? So major thing is that before you can apply the cosine rule, if you look at what we have inside in this case now, you realize that we have been given, look at this, what do you have here? Before you can get A, we have B and C. B, C, together with capital A. Where is B? This is B. This is C. And this is capital A. So meaning if you have been given two sides and the included angle. Two sides and the included angle. So that is when you can apply what? Cosine rule. When? Two sides, when you are given two sides and the included angle. That's one of the ways. Now, if you look at what we have here too, we can decide to make cos A the set of formula. If you make A or cos A the set of formula, we realize that we'll be talking about A, B, and C. So another time you can also apply your cosine rule is when you have been given three sides, all the three sides have been given. So that is when you can apply that. So that is what you mean by the sine and the cosine. So I think that's the major thing that we need to take a look at before we go to the main thing today. Okay, so the main thing today, let's just take a quick review of the sine and cosine rule before we go to compass BM. Now, a quick review. Let me share another thing with us here. Okay. Just to kind of review, I want to quickly review let's quickly review the aspects that we have explained now. That's the sine and cosine rule. If you have IXL, you can go to okay, yeah. So go to IXL.com, mathematics under algebra. Under algebra, then you try to locate trigonometry. So when you locate trigonometry, okay, sorry. I think that should be in not in trigonometry, not in algebra. So we can find that in geometry, yeah. So locate your geometry, and in geometry we'll see laws of sine and laws of cosine. So that is where you have it. So once you are in trigonometry, just go to, so once you are in geometry, we have trigonometry under geometry. Yeah. So just go to solve a triangle. Trigonometry is R, letter R. Then go to 13 there. Go to 13. Oh, sorry. Let me quickly share my screen. Let me share my screen. So I will share my screen now so that you can see what I'm trying to do there. Okay, so you can see my screen now. You can take your this thing to the horizontal form. So look at this. In solving this triangle, which law must you use first? So we want to solve this. What are those things that you have been given? They have given us angle Q. Angle Q has been given. Let me annotate. Yeah, angle Q has been given. So which other thing have been given? We have been given small r. This is small r. We have also been given this. That's small s. So if you look at it, you realize that we have been given two sides and the angle between them in form of RQS or SRQ. So there's nothing you want to use there. We have said before you can use sine, you must be given maybe small p and big P, or small q and big Q, or small r and big R. So either you are given this or this or this before you can use what your sine rule. They will give you same letter. But here now you can't see same letter, you can only see R, small s, and big Q. So it means we are using what? Cosine rule. So it is cosine rule we'll be using. So just pick cosine rule. So you can see that that is correct. So let's see. In solving this triangle, which law must you use? If you look at these two, you realize that we have been given still in the same form. This is the side that is opposite to E. We call it small e. The side that is opposite to G is this. We call it small g. So we have been given E, G, and F, big F. So it's still the same thing. In this case now, we have EGF, EGF. For us to apply sine rule, they must have given us E and small e, or G and small g, or F and small f. But that is not the case. So it means sine rule is not applicable. So it is cosine rule that you must apply. Cosine rule that you must apply. So cosine rule. So that is on that one. So in this case, which one must you apply? So if you look at this one too, I don't need to stress myself much, but they have given us two sides and the included angle. Two sides and the included angle. So look at this, and this. So in that case, this one is what? Is small d. And this one is what? Small f. So we have a D, E, F here. Before you can apply sine, they must have given you DD or EE or FF, and they have not given us like that. They have given us FD and big E here. So it means we are still using cosine rule. So cosine rule. So I think we can just, after this, we can stop and go to the next one. Okay. So look at this. They have given us this. They have given us this. Let's look at what you have been given. They have given us W. Sorry, they have not given us W, but opposite to W, they have given us small w. They have given us okay, those are the things given. Now, so looking at it now, they have given us big Y, big X, and they gave us small w. You can see there's nothing the same here. There's nothing the same. Exactly. But at the same time, we have not been given two sides and the included angle. You get it? Look at what you have been given. This, and this. So what you just do there is that since you have been given two angles, you can easily find this angle. So once you get this, it means they have given you big W. Indirectly, they have given us big W. So 96 plus 27. 96 plus 27 plus W must give us 180 degrees. So 96 plus that will be 1, 2, 3 plus W equals to 180. So W is equals to 57. So this is 57. So indirectly they have given us that. So meaning that they have given us WW. So it means we are using what? We are using sine. We are using the sine. I hope I'm making sense. We are using sine. So I'm going to stop sharing there. So let's go back to the main topic for today. So now, so I haven't done that. So let's now look at bearing. Sorry. Okay. So we want to go to compass bearing and then 3-digit bearing. I've explained that too earlier. 3-digit compass bearing is when you make use of the 4 cardinal points: the north, the south, the west, the east. And we always refer to either the north or the south. So so that is in compass bearing. So let's just go to some of the questions. I took a poll earlier today, but majority of us were not around, so we couldn't actually go through it. Okay. So let's go to the next thing. Come in. Yeah. So now this is the first question. The bearing of P from Q is X, where X is between 270 degree and 360 degree. Find the bearing of Q. Find the bearing of Q from P. I think this was the question I put on the poll. Maybe I should repeat the question again. So this is the question. So I can see that we have some that are available now. So let me quickly bring up the poll again so that you pick your answer. I want to assume that you can solve this question. So you pick. I hope you can see a poll now. Yes, look at the poll. So can you pick your answer? The bearing of P from Q is the same question. The bearing of P from Q is so it's X, where X is between 270 and 360 degree. Find the bearing of Q from P. So just pick your answer so that we go. Then I can explain that. Okay, one person has picked. Okay, I'm expecting others to pick. So can we move on? One person has picked. I need one more or two people to pick. I need one more or two people to pick. Can somebody pick more? I'm still expecting. Okay, yes, two. Okay, I think two people have picked now, so we can go. Okay, so, and the two people got it correctly. That's great. Okay, so how do we do that? Yeah, so two have got it. Those two, that's great one. So, the answer is actually x minus 180. X minus 180. That's great. So now let's now look at it together. Let's look at it together. Okay. So now in this particular question, what you just need to do here, what we need to do here is the bearing of P from Q is X, where X is between 270 and 360. Find the bearing of Q from P. Now, the bearing of P from Q is, it means when you go to Q, the first thing is that you go to Q. If this is Q and this is 0, we know we must start from the north. This is 90 degrees, this is 180 degrees, this is 270, and this is 360. So what they are telling us is that our X is around here. It means our P will be somewhere here. So the bearing of P from Q is X. So from here to here is X. Then what is find the bearing of Q from P? It means you come to P. You measure from the north of P. And you measure in a clockwise manner up to the line that is coming to Q. What is this? That's what they want us to find. What is this? And from our Z angle, this is like Z. The angle here must be the same thing as the angle here. So if the whole of this place is what? Is what? Is X. Then how do we know from here to here? From here to here. We move 180 from it. So it means X minus 180. This place will not be what? X minus 180 degrees. So that's the solution to that. The next question. We have a question here. Says 3 observation posts P, Q, and R are such that Q is due east of P and R is due north of Q. If PQ equals 5 kilometers and PR equals 10 kilometers, Find question 1, QR. Find QR. Question 2. So find QR to 2 decimal places. And question 2, find the bearing of R from P. So how do we do that? So I want to believe that some people are already trying that. So let's, for the purpose of those that may not. So how do we do this? ZTV observation posts P, Q, and R are such that Q is due east of P. You know, I said it earlier that anytime we are talking about bearing, you watch out for the word from. That was what we use here. From Q. That was the reason why we started from Q. So sometimes sometimes we don't have from. But what we have there is what? We have off. So that is what you can see here. Such that Q is due east of P. East of P. So the first thing you are going to do is what? Get your P. So let's assume that, just put P around middle here. Let's say this is P. I think Abdul Basit need to mute himself so that we don't hear your background noise. Okay, that's good. And Razak too. Okay, so, okay, thank you. Thank you. Let's move on. So let's move on. Sorry. Okay, don't worry, I will explain. So for question 2, they said TV observation posts P, Q, and R are such that Q is due east of P. That's the first statement we want to try to explain, interpret it. So this is the first thing we are interpreting. Q is due east of P. So of what? Of P. They assume that we know P. So we assume a point for P. Let this place be P. So anywhere you are getting your P, you are putting your P. Draw the 4 cardinal points on it. This is the north. Because they have mentioned east, assuming they use angle, we are just going to use just north. And then measure your angle in a clockwise manner, like this, the way our clock works. But in this case, they have mentioned the cardinal point, the compass bearing. So just, this is our north, this is our south, this is west, and this is east. So since they have said what? Q is due east of P. Q is due, this is P. So you can find Q east of P. This is the east of P. East. So Q will be around anywhere, somewhere, anywhere here. So let Q be here. We are through with that. You go to the next one, and R is due north of Q. Of what? Of Q. So go to Q. Draw your 4 cardinal points on Q. This is Q. 4 cardinal points: north, south, west, and east. So in this case now, where is the north of Q? This is the north of Q. They said what? R is due north of Q. R is north. R is at the north of Q. So this is R. We have interpreted two statements. The first one, Q is due east of P. So whoever that have got the answer, you can just you can throw it at the chat room. So in this case, Q is due east of P. We have done that. Q is east of P. And R is what? North of Q. North of Q. So they say if PQ is 5 kilometers, where is PQ? This is PQ, 5 kilometers. And PR is 10 kilometers. Where is PR? This is PR, 10 kilometers. So find QR. This is QR. This is QR. This place. So from the way we have labeled our triangles, the side that is opposite to, look at it, this is opposite to what? P here. So you can just call it small p. That is what they want us to find. So how do we get this? From what I've explained earlier, anytime you have been given two sides of a right angle triangle and you want to find the third side, the only thing you can use there is what? Use Pythagoras theorem. So what does Pythagoras theorem says? It says that what? The hypotenuse, which is what? The longest side, that is 10 squared, equals to what? The sum of the what? The squares of the two other side, equals to P squared plus 5 squared. So 10 squared will give us 100, which is equals to P squared plus 5 squared is 25. So take 25 to the other side. We have 100 minus 25 equals to P squared. And then 75. So P squared equals to 75. So P will be equals to square root of 75. So you just check your calculator. What's the square root of 75? And I think that should give us 8.660. 8.660. So they said to 2 decimal places. So it means our answer will be what? 8.66 kilometers. So that is how we find that. I hope that is clear. Just like I said, we have been able to find, they said Q is due east of P. So go to P and use your cardinal point to locate east. Go to Q again to locate north. R is due north of Q. And put the this in there. So that is the solution to that one. Let's quickly move to the next one. So the next question, they said find the bearing of R from P. R from P means you go to P. You go to P and you measure from the north of P in a clockwise manner up to the line that is going to R. P from R from P. So you go to P, measure from the north of P in a clockwise manner up to the line that is going to R. So this is the line going to R. This is what they want us to find. We want to find this angle. So there are several ways in which you can find this angle. Number one way is that this angle is same thing as this angle. Because they are Z angle, they are alternate. So what you just need to do is that find this angle theta. So once you get this angle, it's still the same thing as this. Or you find this angle here and you remove it from 90. You know, everything here should give us 90 degrees. L shape, you always give us 90 degrees. So whatever you get here, you just remove it from 90 to give you the remaining one here. So, but let's just get it directly. Let's find angle R. This angle here. So how do we get that? We have known this place. This is hypotenuse. Because we are looking for this angle here, this place will be called what? Opposite. So that is from our SOHCAHTOA. From our SOHCAHTOA, Ka, tua. It means we have O and we have what? H. So where do you see O and H? It's under sine. So it means you are going to apply sine. Sine theta equals to what? Opposite over hypotenuse. So sine theta is that theta we are looking for, which is equal to our opposite is what? 5. Our hypotenuse is 10. So sine theta equals to 5 over 10 will give us 0.5. So if you press your calculator and check sine inverse of 0.5, it will give us 30 degrees. So it means we can say that the bearing of R from P is 0.30 degree because we don't like 2 digits. We leave it in 3 digits. That's why we call it 3 digits bearing. So 0.30 degree. So that is the solution. If you cannot see your screen clearly, just try to put your phone in horizontal manner. So we have been able to solve 2 questions on bearing. Actually, I planned 5 questions, but I don't know if our time will permit, if the time will permit us. So let's quickly go to the next question. So going to the next question. So we have a question here. It says point X, Y, and Z are located in the same horizontal plane such that Y is 12 kilometers north of X. Okay. Y is for 12 kilometers north of X, and Z is on a bearing of 270 degrees from X. Sanusi Razak, I hope you understand the last question we solved. I can see that the network logged you out. So
Yes,
how do we
sir.
solve this? Okay, all right. So let's move on. Thank you. So point X, Y, Z are located in the same horizontal plane such that Y is what? 12 kilometers north of X, and then Z is on a bearing of 270 degrees from X. So let's go. The first statement that we have there, point X, Y, and Z are located in the same horizontal plane such that all those ones are useless. The major thing that we need there is Y is 12 kilometers north of X. So they assume that we know where X is. So just pick your X anywhere around the middle here. Let's say this is X. Y is 12 kilometers north of X. So this is north of X. This is south of X. This is west of X. This is east of X. So what we need is what? 12 kilometers north. 12 kilometers north. 12 kilometers north of X. So this is where you have Y. And it says Z is what? On a bearing of 270 degrees from X. This is also X. 270 degrees. When they mention angle, you go to the north of that X. From X, go to the north and measure in what? In a clockwise manner. This is up to 1, this is up to 790, up to 180. This is 270. So this is 270 directly west. So this is where you can find Z. So you can draw your cardinal point there, north, south, west, east. So the question asks is if xz is 6 kilometers, this is 6 kilometers, and they have given us y is 12 kilometers north before. Yeah, this is 12 kilometers. So they said what? Calculate to what decimal place? YZ. This one is very simple. YZ. So what do we do here? You see the same what? The Pythagoras theorem. So this is the hypotenuse. So hypotenuse, which is opposite to what? Angle X. So that's small x. So we just say that what? X squared equals the sum of the squares of the two other sides. 6 squared plus 12 squared. 6 squared is 36 plus 12 squared is 144. So when you add them together, that will give you 180. So x will be equal to square root of 180. So if you can use your calculator to do that, and that will give us 13.42 or 13.416. So 13.416. And they said approximate to 1 decimal place. So x will be equal to 13.4 kilometers. So that's the solution to that. The next question we have here, they said a point P is 40 kilometers from Q on a bearing of 061 degree. Calculate, correct to 1 decimal place, the distance of P to question 1, north of Q. Question 2, east of Q. So you can also try that. But because of time, for what I have here, the point P is 40 kilometers from Q on a bearing of 061 degree. So they want you to calculate, correct to 1 decimal place, the distance of P. So let's first interpret the first statement. A point P is 40 kilometers from Q on a bearing of 061 from Q. So come here and locate your Q. Let's assume that we have Q here. So it is from Q. So on a bearing of 061, so from the north, 61 is not up to 90. 61 will fall here, somewhere here. So this is 61 degrees. So it means our P will be somewhere here. And they have said the distance is 40 kilometers. So since the distance is 40 kilometers, from there, we can now find, what did they ask us? Calculate correct to 1 decimal place, the distance of P to the north of Q. This is P. North of Q, this is north of Q. Anywhere here is the north of Q. So they want us to find a direct distance from P to the north of Q. So this is what they want. This particular distance 1. The second one, they said the distance of P to the east of Q. P to the east of Q. This is north, this is south, this is west, this is east of Q. So it means you trace these two. This is the east of Q. So they want you to find the distance of P to the east. This is what, that's distance 2. So they want us to find this and this. That's what they want us to find. So we can just find, it depends. You see this D1 here is still the same thing as D1 down here. The D2 here is still the same thing as the D2 here. So you can decide to use this triangle or you use this triangle, whichever one. because they have given us 61 for the upper triangle here. Let's use the upper one. So since this is the angle, the side that is opposite to the angle will be called opposite. And the longest side here, which is 40, is the hypotenuse. So we want to find opposite now for the first one. For the second one, we are looking for the adjacent. Let me remind us of our SOHCAHTOA. So because we are looking for opposite, we know hypotenuse. That's OH. So it means you are going to use sine 61 degrees equals to opposite, which is D1, over hypotenuse, which is 40. So if you cross multiply over 1, D1 will be equals to 40 sine 61. If you use your calculator or 4-figure table to know what the value of sine 61 is, it is what? So this will be 40 times sine 61 is 0.8746. So if you multiply it by 40, it's going to give us 34.98. But they want us to solve it to what? To one decimal place. That will be D1 will be equals to 34 points. So you can see this 9, you are supposed to solve it, but this one is also more than 5, is up to 5. So approximate it. So this one will become 10. So write 0, carry 1 here. So that will be 35.0. You must put that 0.0 there because they want to one decimal place. 35.0 kilometers. Then for the other one, the second one, D2. So that's adjacent and hypotenuse. That is car. So what we use there is what? Cos 61 equals to what? Adjacent, which is D2 that we are looking for, over what? Over hypotenuse, which is 40. So our D2 will be equals to 40 cos 61. So it means we also need to find what cos 61 is. And if you use your 4-figure table or calculator, you have it as what? 0.4848. So if you use it to multiply 40, it will give us 19.39 kilometer. But they want us to approximate. That will be 19.4 kilometer. That's our D2. So I want to believe that that is clear. So then we go to the last question for the day. So the last question says that a boy walks 6 kilometers from a point P to a point Q on a bearing of 0.65 degrees. He then walks to a point R, a distance of 13 kilometers on a bearing of 146 degrees. Sketch a diagram for his movement. Then the second question, calculate correct to the nearest kilometer, the distance PR. So to solve this question, you have to take it statement by statement. Don't be intimidated by the bulky question. So just come, a boy walks 6 kilometers from a point P to a point Q on a bearing of 0.65 degrees. That's the first statement. A boy walks 6 kilometers from a point P. This is what we are after, from a point P. So come to the middle here. pick point P. So come to the middle. Let this be point P. So from a point P on the bearing of 0.65 degrees, this is not. 65 is before 90. So it can end here. This is 65. So a boy walks 6 kilometers from point P to a point Q. So this point is point Q. On a bearing of 0.65 degrees. We are through with what? The first statement. Let's move to the second statement. He then walks to a point R, a distance of 30 kilometers on a bearing of 146 degrees. 146 means is more than 90. So 146 somewhere here. So you can have something of this nature. 146. What will you add to 90 to make it 146? That's, you add what? 56 to 90 to make it to become 146. So it means this small place is 56. They may also ask you, what is this small place? So it means to get this small place, you remove 146 from 180, or you remove 56 from 90. So whichever one. When you do that, you should have 34. 34. You realize that 34 plus 56 will give us 90. 34 plus 146 will give us 180. So this is 34. Then from Z angle 2, since this is 65, the remaining one, the one here too is 65. Z angle. So from there, we can originally calculate this. We can calculate the 65 plus 34 will give us 99. So this is where we have R. So I think we have been able to sketch the diagram. Then they said calculate to the nearest kilometer distance PR. Distance PR. So just find the distance. So let me see if I can. Okay. Okay, here, let me, I want to try to get a perfect. Okay, it's better like this, yeah. So find that. So that is what we want to find. How do we get that? So to get that one, what do we do? They gave us this place as 13 kilometers. Now, from what we have learned, sine and cosine rule. So the one that we can easily apply here is what? Cosine rule, because of what you have been given. You have been given two sides and the angle between them. And then they have labeled the angle for us. This is P, angle P. This is angle Q. This is angle R. Can we label the sides too? The one that is opposite to angle P is called small p, which is this. The one that is opposite to Q is called small q. The one opposite to R is called small r. So they want us to find small q. So using cosine rule, we have q squared will be equals to p squared plus what? R squared minus 2pr. I think we have stated that formula before. Then cos q. So what's our p? Our p is 13. 13 squared plus r, c squared minus 2 times 13 times 6 cos 99. So 13 square will give us 169. 6 square will give us 36 minus 2 times 13 times 6 will give us 156. And what is cos 99? If you check your 4-figure table or calculator, our cos 99 is minus 0.1564. So when you multiply, minus times minus will give us plus. 156 times 0.1564 will give us 24.403. So that will give us 24.404. Then when you add 169 plus 36, it will give us 205. So add 205 to 24, it will give us 229.404. So that's our Q squared. But we are looking for Q. That will be square root of 229.404. So if you do that, you should be having around 15. That's around 15 point. Okay, that's 15.14. So which will be equals to 15.146. But they said to the nearest kilometer. To the nearest kilometer. So they don't want to see any decimal point. So our answer is 15 kilometers. So that's the solution to that question. So I think with this one, we are coming to the end of the trigonometry. We are coming to the end of trigonometry. Well, it depends on the. So for the assignment, I have these questions. You can just screenshot it. Y is 60 kilometers away from X on a bearing of 135 degrees. Z is 80 kilometers away from X on a bearing of 225 degrees. Find the question A, distance of R from Y. B, the bearing of Z from Y. Then C, number 2, a cyclist starts from a point X and rides 3 kilometers due west to a point Y. So at Y, it changes direction and rides 5 kilometers northwest to a point Z. When you say northwest, it means at the middle of north and west. That is by 45 degrees. You know, between north and west is 90 degrees. So the middle would be what? 45. So that's why they use the word northwest. So say, how far is E from the starting point? Correct to the nearest kilometer. Question 2, find the bearing of Z from X to the nearest degree. So those are the questions that we need to consider. So as time goes on, actually we have just ended the trigonometric series. This is the 5th week for our trigonometric series. So I'm going to announce to us, I will announce to us if possibly we should be starting another aspect by next week. But so far, the turnout has not been encouraging. So we are going to look at that. If that is